Welcome students. In previous lecture we discussed about the types of the thermometers. Now in this lecture we learn about the absolute zero temperature. Okay, what is meant by the absolute zero temperature? Absolute zero temperature means what? We know in the Celsius scale we consider the ice point is a 0 degree Celsius, but the same temperature in the Fahrenheit scale consider as the 32 degree Fahrenheit. Okay, but we not confirm about the which one the really zero readings. Okay, now basically we know the one things. In case of the ideal gas, we know volume of the gas is directly proportional to temperature. Similarly, the pressure, when P is constant, and the pressure of the gas is also directly proportional to the temperature. Okay, then simply PV, both are directly proportional to temperature of that gas. Okay, suppose I plot a graph pressure versus temperature and the volume versus temperature for and the ideal gas or any real gas. I obtain the nature like this. Just I consider here, I take the temperatures reading on the x-axis and say pressure P on y-axis. Okay, what happens as the temperature increases, pressure is also increases for constant volume. Okay, constant volume V. What I obtain? But remember that at the 0 degree Celsius, here temperature in Celsius, pressure of the gas are not like 0. Means suppose somewhere here and I obtain the graph like this. Say any particular gas, say gas 1. I perform the same experiment with other one. Again I obtain the same nature in case of the another gas also. Say gas 2. Again one, say gas 3, and so on. Means they are the different gas. I obtain the same nature. As the temperature increases, pressure is also increases. But remember that at the 0 degree Celsius, the pressure of the gas is not a 0. There exist some values. Okay. Similarly, I draw here the another graph. Temperature versus volume at constant pressure. Okay, I obtain the same nature. As the temperature increases, volume is also increases. For another gas, as the temperature increases, volume is also increases. For the another gas again, as the temperature increases, volume increases. Okay, but now whether we observe, the nature is practically possible. As the temperature increases, volume increases. But theoretically, if I extend the same graph in backward direction, here temperature positive, here the value of the temperature is negative, I obtain somewhere here the crossing point like this, like this. This is not a fine sketch, so I draw another diagram. So here, like this. Same concept is here also. Means somewhere here they crosses to x-axis in negative values. Okay, practically it is not possible, but we extended line in backward direction. Say 1, 2, 3 gases. So that value are something 273.15, and here is also 203.15. In both cases we obtain the exact value. Means theoretically, what is meant by theoretically, at this temperature, negative temperature, because 0 is here, so the left side values are negative temperature and the positive. At this value, volume of the gas is coincide with the x-axis, means 0. Practically such not possible, but here we extend the graph in backward side and we predict exact figure 273.15 degrees Celsius, and this point is referred as absolute zero temperature. In this case also, if we extend in back side, we obtain the same value 273.15 degrees Celsius. Means the pressure of the gas at this temperature will be, or maybe, we said maybe 0, because practically it is not possible, because the pressure of gas never becomes 0. So, but theoretically we predict by using the graph, we find out the value. One more important thing is here, we use the different gases, gases 1, gases 2, gases 3, in pressure also, gases 1, gases 2, gases 3. The slope of the gas is different in each cases. The slope of the gas is different, but even though the all graphs, all curves crosses at the same point, and that's why now this minus 273.115 degrees Celsius temperature is considered as a absolute zero temperature. Is it clear? The another one thing is here, at the same point we obtain the triple point of water. Now what is meant by triple point? So to start the further discussion, we discuss about the what is meant by the triple point. Triple point means a point of the graph at which the material, particularly we say the water, exist, or the all three stages exist at that point. Means solid phase, liquid phase and gases. All the three phases coincide at a single point. It is possible, and that point is called as the triple point. Okay, and that triple point of the water is considered as 1 by 273.15 degrees Celsius minus, and this is approximately 0.01 degrees Celsius and not the exact 0. Okay, not the exact 0, it is 0.01 degrees Celsius. and now the universally this value is accepted. Okay, this is about the triple point and the absolute zero temperature. From this, once we define it is the absolute zero temperature, we modified the previous scale and we refer as this minus 273.15 is the absolute 0 degree Kelvin. 0 Kelvin. Why you call it the Kelvin? Because first is suggested by Kelvin. Now honor of this, we use this scale and as a ESI system. Okay, now look here, according to that scale, temperature will be T is equal to, what will get? T is equal to Tk minus 273.15 divided by 100, because the intervals are same. There is no change in the any intervals. Intervals are same in both cases, Celsius scale and the Kelvin scale. In both cases the intervals are same, that's why we here denominator and we obtain this one. Now by using this formula and previous two, we can calculate or we can convert the factor from degree Celsius to degree Kelvin to degree Fahrenheit and so on. So here I take one example of conversions. Let's consider the conversion factor. So first I write all three equations of scale. Tc divided by 100 is equivalent to Tf divided by 32 divided by 180, because in Fahrenheit scale the interval is subdivided in 180 parts, is equivalent to Tk, K for Kelvin, minus 273.15 divided by again 100. That relation indicates the equivalence or equality between the three different scales: Celsius scale, Fahrenheit scale and Kelvin scale. Okay, now we take one example. Suppose the given temperature in the Kelvin is 24.57 and we have to convert this in degree Fahrenheit and in degree Celsius. Okay, so just by use this formula and find out. So solution is here. Tc means temperature in Celsius. I put the value of this Tk in this equation. First I compare these two. So what I get? Tc divided by 100 is equal to Tk minus 273.15 divided by 100. In both cases 100. So what implies that? Tc is nothing but Tk minus 273.15. So simply I put here value of Tc 24.57 minus 273.15. Okay, so the obtained value is, if we calculate this simple term, we get minus 248.58 degree Celsius. Now it is in Celsius scale. This Kelvin, K, not write like this. This is the wrong. In Kelvin, we just write whatever be the temperature is given, 24.57 Kelvin, and not like this, 24.57 degree Kelvin. This is wrong. This one is the correct. This K should be capital. Okay. No need to write the degree here in Kelvin system. Remember that. Okay. Now the next task is conversion of Fahrenheit. Okay, so I compare another equations. TF minus 32 divided by 180 is equal to TK minus 273.15 divided by 100. Okay, now the required value is TF. So I modify this equation for TF. TF is equal to 180 divided by 100 into TK minus 273.15 plus this 32 convert to the right side and become plus. Okay, so simplify this, 0 0 get cancelled, just sort out 9 by 5. Okay, and the value of TK is given 24.57, yes, am I right, minus 273.15 plus 32. Just this is a simple algebra, just calculation part, make the first subtraction, and lastly we added these 32 terms. So what we'll get, I provide you the direct answer. F is equal to minus 415.44 degree Fahrenheit, but we have to check at the home, just it is division and subtraction. Okay, TF means temperature in Fahrenheit. Look here, the given temperature in Kelvin, here the temperature in Celsius and temperature in Fahrenheit. Actually, physically all temperatures are the same, but in different scale they indicate the different numerical value. So we must have the idea to convert how the temperature scale is converted. But the internationally accepted system now is the Kelvin. Why? Because here we define the absolute zero temperature. Initially, to find out the temperature, we use the 2 points. One is the steam and freezing point. Both points are required. But once we define the Kelvin scale and the triple point, we use the only single freezing point, and we can calculate the temperature, and this system is very accurate. To find out the physical calculations. Okay, now the next point is the ideal gas equations, the behavior of gas. In briefly, we have already discussed the all ideal gas equations. V is directly proportional to T, and P is directly proportional to T. This is for constant P. This is for constant V. Yes, if we calculate these two terms, we obtain the third one. V is equal to some constant V by T, and P by T also we obtain some constants. The first one is the volume related gas is called as the Charles law, and the second one, the pressure is directly proportional to, is referred as the Gill-Stokes law. And by using these two, just P is inversely proportional to V when T is constant. and P is inversely proportional to V when T is constant, and this is nothing but your Boyle's law. By comparing all these three equations, we find out the universal ideal gas equation. PV is equal to RT, where R is the universal gas constant. But that all portion we will continue in next lecture in details. Okay, just I here give the introductory concept. P is directly proportional to V. P is directly proportional to T. V is directly proportional to T, and P and V are reciprocal to each other when temperature T is constant. And from these all three equations, we find out this universal gas equation, and this equation is nothing but the ideal gas equation, and R is the universal gas constant. But all these terms and some calculations we will continue in next lecture. Okay, thanking to all of you. Thank you very much.